All right. Here we are with week 2, remote learning. We're going to look at chapter 7. Last week we looked at a review of chapter 6, going over the periodic table. Here we're going to just really focus on ionic bonding. I know it says ionic and metallic, but really all I focused on was the ionic bonding. This is a shortened PowerPoint version. You have the full one that's on my Google Slides. And again, if you have any questions, just email mark.boer@addisonschools.us. So 4 main objectives just for this week. We're going to look at the octet rule, how that applies to our ionic bonding. We're going to look at how both cations and anions form, since they are what make up ionic bonds and ionic compounds. We'll look at how to write ionic formulas, and that would be through what I call the crisscross method. You look at how to name them. We'll do that in chapter 9 as we get in the next week or two. And then we'll just look at what are the 3 main properties and just being able to know what are the properties of ionic compounds. In order to do anything, we have to know valence electrons. Valence electrons are the outer level electrons, basically the highest energy level that you get to. When we look at it, we do electron configurations. We get to that highest number, and then we count the number of electrons that are in them. Those are the electrons that are going to be involved in any type of bonding. The rest of them, as you see there, they're called the core electrons, or all electrons that are not part of the outer level electron. We don't even really care about those. We're focusing in on the valence electrons because those are the ones that are going to end up participating in the bonding. We'll look at them both for ionic bonding and then next week when we do covalent bonding. And basically, they're outer level electrons. They're only your S and P in the electron configurations. So how are we going to find them? You can do an electron configuration for them all, but that would take a little bit of time to figure out how much. There's a much easier way to find the number of valence electrons. Okay, the number of valence electrons are going to be the ones that are in the same column. So it's also equal to the group number. So as it says there, group 2A will have 2 valence electrons. If we look at the periodic table, we'll make it real simple for all representative elements. For this number right up here where it says 1A, all of those will have 1 valence electron. Where it says 2A, all of those will end. And it's the reason last chapter we talked about them having the same chemical properties are because they have the same valence electrons. So we just have to be able to identify real quickly how many valence electrons they have. 1, 2. We're going to skip the transitions because those guys can have multiple. That's the B section here. You see the B there, all the B's. We pop up over onto this side and we get to the A's again. And those are Roman numerals. We have 3A, 4A, 5A, 6A, 7A, and 8A, sometimes just labeled 8. And so these will identify how many valence electrons we have in each one. So you got 1, 2, 3, 4, 5, 6, 7, and 8. And these guys are not going to participate in any type of bonding because they already have their 8 valence electrons. So we look at the 1, 2, 3, 4, 5, 6, and 7. If you just want to take the 1 off of the 13, the 1 off of the 14, and think 3, 4, 5, 6, and 7, you can do it that way too. But those are going to be the electrons that we're dealing with. And we need to be able to find out how many valence electrons they have very quickly. And all you need to do is look at a periodic table. So that octet rule that I was talking about, if you count up the number of S and P orbitals, you get to 8. There's 2 in the S and 6 in the P. So you get to 8. That's where the word octet comes from. In other words, the ones that I just said on the end, those Nobel gases, the ones that were in group 8 or 8A, those already have 8. They're completely filled. So basically, we can think of the octet rule as trying to get to 8 or trying to be like the Nobel gases that have 8. So that's ultimately what the octet rule is trying to tell us. We want to get to that 8. How are we going to get to it is the question. In ionic bonding, we're going to transfer electrons. So